G'day guys, welcome to the first in a series of lectures which will look at our universe and how it began. We're going to look today at describing and listing the features of the universe around us. We're going to look at what is in the night sky, what things we can see and where they come from and how they sort of relate to each other. There are five main features of the universe: moons, planets, stars, solar systems, galaxies. There are some others as well, but these are the main five that we're going to focus on. Most of these words you would have heard of already. What we're going to look at is just to give you a bit of a more scientific definition of what they are and also how they relate to each other. One thing to notice, however, is that down here, it says here, the development of the telescope during the 16th century allowed scientists to discover and study distant objects in the evening sky. For centuries prior to that, people had been looking up at the stars and wondering what was out there. But it wasn't until we actually developed, I think it was Galileo Galilei that actually developed the telescope, or further developed the telescope, that got us to think about and be able to study those distant objects in the evening sky. Rightio, let's take a look at our first object. Moons. You know the moon. You've probably looked outside and seen the moon, usually during the night, sometimes during the day, but usually during the night. You also know the moon changes phase. Not always a full moon, is it? So it actually goes from full moon and it comes down to the quarter moon and then down into a crescent and then to what we call a new moon, where you don't see much at all. We're not talking today about how those moon phases come about. You can look into that deeper yourself. But really what I want you to know about the moon is that it's what's called a natural satellite that orbits a planet. Our moon is our natural satellite and it orbits Earth. And it's held in orbit by gravity. Okay, so the gravity of Earth holds the moon in orbit. We call our moon the moon. But there are a number of other moons in our solar system, and each of the different planets have a different number of moons and different sizes. For example, Jupiter, one of the larger planets, has about 7 or 8 moons, and the largest of which is called Io. Some of them have large moons, some of them have smaller moons, and they often have different names. So that's moons, natural satellites. Planets. You guys should know that there are 8 planets in our solar system, remembering that Pluto is no longer a planet. It was demoted from its planet status in 2006, so there are 8 planets in our solar system. And the thing that these all have in common, they all orbit around the Sun. So up here in this diagram, you can see our Sun in the centre there, and you can see some of our planets. There's us, Earth, and all of these planets orbit the Sun. In the same way that a moon will orbit a planet, held in by its gravity, a planet will orbit a sun held in by the gravity of the sun. A planet is a large body. It's a large body of mass, and that mass is enough to create a spherical shape. And gravity always has matter pulling together, so it's always pulling inwards. The name planet, the word planet, as with most words in science, comes from the Greek, from a Greek derivative. It comes from the Greek word meaning wanderer. And this is because when the Greeks looked up at the stars, they talked about constellations of stars, so stars that made shapes to them. And what they would notice is that there would be these odd bright shapes which would actually move across these constellations. And those were actually planets moving around in their orbits in relation to the stars behind them. Now that's to do with something called parallax. We'll have a look at those later on and what parallax actually means later on. But the word planet comes from wanderer because the Greeks saw these bright spots wandering across their constellations. Now, stars. Stars are made up of hydrogen, and hydrogen makes up most of the elements, or is the most abundant element in the universe. So stars are made up of hydrogen and they're made up of helium. The reason they have helium, which is only slightly heavier than hydrogen, is because the hydrogen atoms combine to form helium atoms, and this is a process called nuclear fusion. So what happens is you get 2 small hydrogen atoms, and they collide at speed, and there is enormous speed, enormous pressure and temperature, and this pressure and temperature allows them to create helium atoms. When this happens, a huge amount of energy is released, and that's what we call nuclear fusion. Now, nuclear fusion is different from nuclear fission. On Earth, we control, or we harness the power of nuclear fission in order to create electricity. We use this on, that's how nuclear power plants work. So what they basically do is they get large atoms such as plutonium or uranium, and they get these large atoms to break down. And when these atoms break down, they will actually split apart and release energy. This is the opposite. Okay, fission means to split apart. Fusion means to come together. And what happens is you get hydrogen atoms and helium, or hydrogen atoms coming together to form helium atoms. We'll look more at this on the next lecture, and we'll go a little bit more into stars and how their reactions are going there. Now, the next feature of the universe is called a solar system. Now, a solar system you can sort of think of like an ecosystem. Well, you know on Earth that an ecosystem is an environment which contains lots of different plants and animals, all different varieties of plants and animals. And it's a system which works together. And it's all based around one environment. A solar system, solar means sun. So what this is a solar system is a collection of things that orbit around a sun. Those things can be planets, moons, comets, asteroids, meteors. Okay? If we have a look at our sun here, that is the center of our solar system. It has a number of different planets. You can see these 8 planets across the top, which orbit around it, and then around each of those planets there are generally moons. You can see all these moons here. There's Io that I was talking about with going around Jupiter. But it's not just the planets and the moons, there are also asteroids. There's an asteroid belt. There's the Kuiper belt, which is another bunch of asteroids. Comets as well are other things which can also orbit around a sun. So all of these bits and pieces, which planets and moons and asteroids and meteors and comets, all of these bits and pieces revolve around one sun. So this system of items revolve around one sun. That is one solar system. So we have our solar system which revolves around our sun. Now, we're not the only solar system out there. When you get a bunch of solar systems and you put them all together, we call that a galaxy. Okay? Now, we are part of the Milky Way galaxy. So we are one sun, or one part of a Milky Way galaxy, or one star in the Milky Way galaxy. Each spot on this galaxy, this is the Milky Way galaxy down here, this is just another galaxy, but each spot in this swirling galaxy down here, each bright spot is one sun. Each sun will have a bunch of different planets and moons revolving, asteroids as well, revolving or orbiting around it. Okay, so you have a solar system which is all around one sun, and then you have a bunch of solar systems making up one galaxy. So we've had a look at the 5 features of the universe. We've had a look at the moons, which are a natural satellite which revolve around a planet which is a large mass which orbits around a sun or a star. We've looked at stars, which are large balls of gas which contain hydrogen, helium, and undergo nuclear fusion. We've looked at solar systems, which is a collection of those 3 things around one sun, and a galaxy, which is a collection of solar systems. Now, earlier I mentioned the word parallax, and we talked about parallax in relation to the wandering planets, the wandering stars. Well, parallax is the apparent movement of an object when the observer is moving. So the object isn't moving, but the observer is moving. So it's slightly different to what we're talking about, but it still maintains a little bit of it. Let's have a look at this diagram below to see if we can actually see what's going on and what parallax means. Have a look down here, and in July, if we are an observer standing on the Earth and we look towards the stars, we might see a nearby star here. Remember, stars are not all in the same place. Some of them are closer, some of them are further away. So if we look at a nearby star here, in relation to the distant stars in the background, it looks as if it's on the right-hand side of the picture. So you can see over here, this is where that star is, the purple one. 6 months later, the Earth orbits around the Sun. Now, the stars stay in the same spot. As we actually look from this side, we are now looking at the same star with the same distant stars in the background, but it looks as though the star has moved over this side. In July, it was on the right-hand side. In January, it's on the left-hand side. So it looks as if it's moved from one spot to another. Now, this star has not moved at all. What's moved is the actual observer, the person. And what happens is scientists can use this apparent movement to calculate the distance from this sun here to this star here. Okay, and what we're going to actually do is we're going to do a practical based around this, which is called the parallax practical, and we're going to see if we can figure out, using trigonometry, how you can measure this distance here. Rightio, that's the introduction to the universe. What I wanted you to have a look again is to list and describe the features of the universe. So, do you know those 5 features? Do you know how they are different from each other? Can you explain them in different ways? And also what we can have a look at is the idea of the term parallax and how that relates to measuring distances. Hope you enjoyed this lecture, guys.